We are going to cover creating a grass mesh in Blender, then animating and populating that with a multi-mesh and shader in Godot 4. If you don't want to follow either of those steps, there is a link in the description to a public GitHub repository where you can download the GLTF grass mesh and or the materials itself. You can also skip to areas of interest with the chapters below. This process was inspired by Agpute's enchanting stylized grass video for Maya and Unreal Engine. A link to their video is also available in the description. This is Blender 3.5 and we're going to start in a new scene. The first thing you're going to want to do is get rid of everything that's in here because we just need a plane mesh. So let's press A to select every object in the scene, hit X, and then click Delete. Now we're going to want to add a new plane mesh, so we can hit Shift and A to open up the Add prompt, and we can go to the Mesh fold-out menu and select Plane. Now we're going to want this plane to stand up on its side, and to do that we are going to rotate it. So select it, hit R and then X to rotate across the X-axis, that pale red line you can see there, and hit 90 to rotate it 90 degrees. You hit Enter, it is now perpendicular to the ground. We want this bottom bit here to be the base of the grass and this top bit here to be the top, and where this green and red line intersect is going to be our floor, so let's move it so our base is lined up with this floor. If we hit G, it'll move the object around. If we then hit Z, it'll move it on the Z axis, and we can hit 1 to move it 1 meter up. The mesh we created by default is a 2 meter by 2 meter mesh, so moving it 1 meter up works in this instance. Now we're going to want to change over to edit mode by hitting Tab, and we're going to want to scale the whole object so it is much, much thinner. So we can do that by hitting S and then X to scale on this X axis, and we're going to type in 0.1. We want to add some cuts along it, so we have some extra geometry, and we're going to do that with a loop cut. If you hit Control and R, you can hover over one edge and you can see a yellow lines being created here. If we scroll the mouse wheel up, we will create 2 edge cuts, and you can keep going up and you can go down to choose how many cuts you want in your geometry. We're going to make 2 edge cuts, and then you can apply those by left clicking. You can choose where they apply, but that doesn't matter too much to us. Just right click and they'll go to their default positions, and we now have a blade of grass with a bottom part, a middle part, and a top part. I'm going to merge the top 2 vertices so that our blade of grass comes to 1 point. Hit M and merge at the center. And then we're going to want to make our bottom 2 points taper a bit together. So we're going to just scale them down. If you select the bottom 2 vertices, hit S and enter 0.5, it'll now be half the width it was there. I then like the aesthetic of having this lower section be a little bit wider than the top, so I'm going to select these lower 2 vertices, hit S to scale again, and type 1.2. With that done, we can hit Tab to exit edit mode and return to object mode. And we're going to try and bend this blade of grass. And there are a few ways we can do that. You can use proportional editing and move the points around to manually curve it over, but I'm going to do it a bit more procedurally using a modifier. The modifier we're going to use needs a point to reference to bend the blade of grass around. We're going to use an empty for that. So if we hit Shift and A, and we add a new empty, we can select plane axis. We now have this point here. We can reselect that blade of grass, and we can go down to the modifiers panel down here. We can then add a new modifier in this drop down, and we can select, if I can see it, a simple deform modifier. I'm going to expand this a bit so we've got a bit more visible space. So you can see it's bending the mesh, but not in the way we want. To start with, we're going to add the point we are bending around. If you click this button in the origin, it will show us the other objects in our scene, which is just the empty. Alternatively, you can click this eyedropper and then select the empty manually. But I'm just going to click on that drop down and select the empty. So now as transforms are relative to that point on the ground, we're going to want it to be a bend. And you can see right there that it's bending straight over. I want the bend to be a lot more subtle than that, so you can increase or decrease the angle with this angle property. I think 15 degrees is kind of plenty. You can also click on it and type in a value manually. So now we've got that point, we can select these this empty, and based on where it is, the bend will be relative to it. So for example, if I move it up by hitting G and then Z to move the point up, you can see it's going to change where the bend is relative to. That subtle bend is nice enough for me. With that all settled on, we can select our blade of grass and we can apply this modifier. And now the geometry is permanently altered to be in that way. And then we can delete the empty because we don't need it anymore. So select that, hit X and hit delete. So what we want to do now is we want to make a little patch of grass by repeating this mesh and changing its scale and angle. We want this patch of grass so that when it's viewed from above or straightforward or from any side, that it's thick and there's no visible gaps. So I'm going to want about 12 to 16 of these. If we select the original blade of grass, we can hit Shift and G, and then we will get a duplicate. We right click, that duplicate's gone back to its original point. You can see we've got the duplicate in the scene collection here. And we can use all of our transform tools to move and position it around. So I'm going to start by moving it, hitting G, and then pressing X to move it on the X-axis. And then we want to alter the rotation a bit. So I'm going to hit R and then Z, so it rotates around the Z axis, which is going to control the actual facing direction from a perpendicular view. So let's just mess with the rotations a bit. And then we can alter the scale. If we hit S and Z, it will decrease the height of the mesh. And if we do that, we'll need to hit G and Z to move it back down to ground level. There we go, 2 blades of grass. Let's repeat that for the opposite side. Shift D, right click, and then G and X to move it on the X-axis. Let's hit R and Z to rotate it around that middle point. And then for this one, I'm going to make it a bit wider, and I'm going to do that by scaling it on the X-axis. And we're going to apply these transforms to our blades of grass over and over until we have a small square patch of ground to operate in. Okay, so let's speed through this process. If you want to see how these angles look from face on, if you have a large keyboard with a numpad, you can hit 1 to view from the front view, 3 to view from the side view, which has revealed a load of gaps, and 7 to view from overhead. If I swap back to 3, I'm just going to rotate this around so that we've got a bit more fill there, and I'm going to rotate this around so we've got a bit more fill there. Okay, so now we've got about enough blades of grass and it's working from the forward and side view. We can see if we hit 7 that there's quite a lot of space in between these. Now I'm going to fix that by selecting all of them and scaling it in every axis but the Z axis. So if we hit S and then we hit Shift Z, now we'll scale in every axis but the Z axis, and that'll bring them all closer together. So that's going to really help mask some of that overhead, those overhead gaps. And then if we want a bit more than that, we can say take individual blades of grass, we can hit R, and we can hit X and rotate them in their X-axis. Well, if we want the local X-axis, we hit X twice, and then it will tilt them forwards or backwards. Now that we've arranged all of our blades of grass, we can focus on the UV editing part of this. So if we jump over to the UV editing tab, we are going to want to select all of our blades of grass. Okay, jump back to layout, select all of them with A, and jump over to UV editing. So this is going to give us two views, the view on the right being a copy of the viewport we had a second ago, but the view on the left is how all of the UVs of these individual blades of grass look when they're unwrapped. And we're going to be using the information from this UV map to figure out how we're going to colour and move around our blades of grass when we're in Godot. So we're going to start by hitting U, and we're just going to click Unwrap to unwrap all those blades of grass. And you can see we've got all of them there. I didn't expect them to be the same size, and that's because I've missed a step. Okay, let's jump back to the Layout tab, and with all of the blades of grass selected, we're going to need to apply their scales and transforms. Now if we jump back to the UV Editing tab, and we hit U to unwrap them, they will respect their individual heights. So the problem was we'd done a lot of scaling back there when we were moving everything around, and we needed to apply those scales so that this UV unwrap can actually see how big the individual faces are meant to be. So what we want is we want all of these blades of grass, you can see it's lined up as it is in the viewport here. We want all of the bases to touch the bottom. And that just means we need to do some cleanup. So the way we're going to clean up ones like, say, this one, where the base is at the top, is we're going to click this UV sync selection option. And now whenever we select an option, we select something here, it will select the matching item in the viewport on the right. If we hit L while hovering over a selection, it will select the whole linked object. So we can see that this one that's upside down is this one here. All we're going to do is we're going to hit, with this whole blade selected, is hit R, and we're going to type in 180 to flip it 180 degrees. Now we can repeat that for all our blades of grass until they're all oriented the right way. So let's hover over it, hit L, and then hit R, and type 180. You can also manually select all of the points by holding Shift and selecting them, but that L link selection is really handy. Let's hit L and select this last one, hit R, 180. And now all of these are the right way up. For the sake of my effect, I'm going to scale all of these up. I'm just going to hit S, make them all a bit bigger, and hit G and move them up. The only real benefit of that is the effect is going to move the blades of grass the closer to the top of the UV map is, so using the space to its fullest extent will make things more reliable over on the shader side of things. But the key point is have these bases lined up with the floor. Back over to layout, we are pretty much done here. If we hit A, we can select all of them and right click and click join to join all those meshes together. And now you will see in the scene collection we have our one plane that is our merged object. I'm going to rename that to grass, and we can focus on exporting. So if we hit File and Export, Godot primarily deals with GLTF files, so get to GLTF 2.0. I have a folder called Stylized Grass Video, and in that I am going to call this file grass. And with that all done, we can jump on over to Godot. If you've made it this far and want to support me making more Godot tutorials, I now have a Patreon, and if you want to see more I've done, I have a course, Godot for Beginners, that will give you source code and written guides for a scale project in the lovely engine. So, this is Godot 4 stable, and we have an empty project with our grass GLB file in it. The way we're going to apply our grass is we're going to take a multi-mesh instance, and that is a node in Godot that specializes in repeating a mesh over and over in an area in a sort of scattered fashion. Or you have some control over how it'll do it, but by default it's easy for scattering objects like grass. So we're going to start by, in the scene tree on the left, clicking 3D scene as the root node, and we're going to hit Control and A, and we are going to add a multi-mesh instance. This multi-mesh instance needs a mesh that it's going to copy, so our grass, and it's going to need a mesh that it's going to apply that grass mesh to. So we can add a plane in here, and we can scatter that grass mesh all over it. So let's add a mesh instance that's going to be our base. So Control A, add a mesh instance 3D, and I'm going to rename that to grass base. And then we're going to want our grass file. Well, we're going to want our grass GLTF file, which is this one here. So if you find the GLB file in the file system, we can right click on it and click instantiate, and now we get our grass. And we're just going to want that as a child of the root. So we need access to the mesh instance itself within this GLTF file. In order to get access to that, because we've just got this node 3D at the moment, we're going to want to right click on this grass, and we're going to want to check editable children from the dropdown. And now we can see this yellow named grass mesh that's visible right there. Let's go back to our grass base in the inspector and let's add a plane mesh. In the mesh property, we're going to select a new plane mesh and we're going to click on this plane to expand it, and we're going to set the size. I'm going to make it quite big, 30 meters by 30 meters. You can see in comparison how big these blades of grass are and the space we're going to fill. If we select the multi-mesh instance now, we have everything we need to actually get this mesh populated with those. So there's this multi-mesh drop-down that appears at the top of the viewport when you have a multi-mesh instance selected. If you select that, you'll get a populate surface option, and then within there we can do all the setup we need. So our target surface is this plane mesh we're going to apply our effect to. So we're going to select the grass base. And our source mesh is the mesh we want lots of copies of, so our grass. So select the yellow named grass mesh. After that, we're going to want to choose a number. I'm going to start with, say, 5,000 and see how it looks. And that is an awful lot of grass. I might be able to get away with less than that. So I'm going to repeat this process. I'm going to click the populate surface option. These options will remain here, but I have noticed if you navigate to other scenes, these properties get lost, which is a pain. So yeah, it's easiest to edit it now right after I've created things. I'm gonna just try 2,500 and see if that's plenty. And unfortunately, that's not plenty. We're getting some big gaps here. So let's just do about 4,000 and call it. There we go. So now we can focus on the actual appearance of these blades of grass. You may notice that the blades of grass are only visible from certain angles in a way that's quite peculiar. When you create meshes in Blender, the actual mesh themselves is only one-sided, so when you open it in Godot, these meshes will disappear when viewed from certain angles. We're going to be able to patch that up within the shader itself. So first of all, something that's quite messy, at least at the moment, is having all of them casting individual shadows. I'm just going to get rid of that for the moment. So I'm going to jump into my multi-mesh instance 3D in the scene tree. I'm going to find the cast shadow option. So in the inspector under geometry, we can change cast shadow to off. And now we just get our varying white to grey blades of grass. We can now start applying actual effects to the grass itself by adding a material, and we're going to add that material to the multi-mesh instance so it applies to all of the grass it's created at once. So in the material override property, we're going to click the drop down to the right of it and create a new shader material. If we expand that new shader material, we can add a new shader. And within this, we're going to use a visual shader, which is a massively improved system in Godot 4. So we're going to select a visual shader, and we're going to name the file grass. And click create. If we click on that grass file in the shader property, it will expand the shader editor in the bottom panel. And with that, we will get a view of how our we will get our viewport, and we will have our shader editor itself. We're not going to need to view any of this stuff on the sides. I may be able to go into distraction-free mode. Yeah, there we go. So this distraction-free option will just get rid of the inspector in the scene tree, and you need to click it again to get that back. So with this shader itself gives us control over a whole bunch of properties using graphs and nodes. We're going to start by setting the color because that's easiest. And in this drop down over here on the left, we have access to a vertex and fragment shader. Vertex is used for positioning the actual object itself, and fragment is used for coloring. So there are a couple of properties we can do to control how it's going to interact with the light at the moment that's going to make things a bit prettier. If we drag from this normal option, we can create a new node, and we're going to want to select a vector compose. This is going to let us create a vector 3. So the normal is the way that this mesh thinks is up, and we want that to be straight up at the moment. So if we change the y value in this vector compose to 1, we have a vector that points straight up. And now every point on this mesh thinks straight up is the angle it should use for how it's going to be lit. And I'm going to also drag that into the normal map slot. And now our grass is looking a lot more uniformly lit. Every segment of the grass is going to be shaded the same way too, so it's going to hide those seams on the mesh themselves a bit. After that, we can also control how it's affected by light by fiddling with this roughness value. If we drag that over into a new slot, we can select a constant and find a float constant, and now our roughness is going to be set to 0 by default. Now I've just remembered another step that would be nice, so I'm going to exit distraction-free mode and head over to this shader material. I think if we expand the shader, there we go, we get options for modes and flags, and these are just extra options for the shader itself. They're going to control how it's going to be lit and stuff like that. This cull mode is what makes the plane only visible from one side, because at the moment it culls the face that it thinks is on the inside, and we don't want it to do that. So if we change the cull mode to disable, we're going to pretty much double the amount of grass we can see, because we can now see the backs of all of those blades of grass. If we expand that again now, we can make some other changes. If we head over to the diffuse mode, we can change that to tune, and we're going to get something a bit closer to cell shaded lighting, which is all, as you can already see, a much more uniform color. Being uniform is nice because it's going to make the grass look fluffier and blobbier from further away. So back into distraction-free mode, let's fiddle with the color for our blades of grass. We want our grass to be a dark green at the bottom and fade to a paler green as we get closer to the top. So we're going to do that by finding out how far up the blade of grass we are, and we're going to do that with the UVs. When we made those UVs, we made it so that the base was at the bottom and the tip was at the top. So we can look up in this shader how far up the UV we are, and if we're near the bottom of the UV, we're near the bottom of the blade of grass. So we're going to need to get the UV to then make assumptions from that. So if we right click on some empty space, we can add a new UV input. It's under the input tab and it's just called UV with capital U and capital V. And we're going to want to get the Y value from this because we don't care how far along that UV we are, we just care about how high we are. So we're going to want to decompose this vector 2. So if we pass that into a vector decompose and change it to a vector 2, we can now grab the Y value. As you can see, it's black at the top, white at the bottom. We want a value that is white at the top, black at the volume. White at the top, black at the bottom, because we want it to be a value about 0 when we're by the bottom, and a value of about 1 when we're by the top. So we can pass that into a 1 minus node. So we drag out from that node, we drag into empty space, and we select our 1 minus node. And you can see if we look at that, we have the same panel but inverted, and you can use this I button to preview values in real time. So now we've got that 1 minus value, we can use the value to determine what color we want our grass to be. We're going to select our color from two options using the mix node, and I think it's a vector 3 mix. So what a vector 3 mix does is we can have a color in one slot and a color in another, and then this weight values determines what our result will be, whether it's closer to the first value, the second value, or a blend. So a weight of 0.5 in a mix will give us a color in between the two first properties. So let's drag our 1 minus value into the weight, and now we will have a value of 0 around the base of the plant and a value of 1 around the top of the plant. In fact, if we just drag that out into our albedo and we return to view our plants, we will see we have all of these blades of grass that are black near the bottom, and then they raise to white as they get higher and higher up. So now we can just swap that black and white value out for an actual green. So if we drag this this pipe going into the A value of the mix node, we can select a new color parameter. Using a parameter gives us a value that we can actually set in the shader itself, so we can reuse this with different colors later on, as opposed to this constant, which is a value you can only change when you're in the shader itself. So I'm going to call this the base color. I'm going to change the default value to on, and now we can set what the default value of base color is. So whenever you first create this material, what color it's going to have. And we're going to want a sort of dark muted green. So if we select sort of a green, and we want to be more saturated, this isn't updating. Okay, I don't know why that didn't update. But using the saturation on this side of the color picker, we can control, we can make the colors visible and then actually select our green. So I'm going to want a kind of dark but not very saturated green. And I've just found desaturated colors give a sort of more pale, wheaty feel aesthetic. So I'm going to go with something like that for a start, and then I'm going to do a brighter green as a second one. So from the B property of this mix node, I'm going to grab into open space, and we're going to add another color parameter. So in this second color parameter, we're going to want to rename it to grass color. Enable the default value again, and we're going to set the default value to a paler green. Do something like that. And now it's going to blend from this value to that value as we go up. And that should be enough that if I expand over here, we can see we've got, we have our grassy colors, although that's a little bit sort of yellowy and a little bit too pale for me. So I'm going to make that value darker. I've ended up spending an awful lot of time fiddling with grass colors, but there we go, that's starting to look really good. So these two colors are 1C400A as the hex code for my base, and I've got 3A9711 as the hex code for the top. And so if I collapse this shader editor, we can see this grass as it is. And that's quite nice. And now we can focus on actually moving these blades of grass, which is arguably the harder part of this whole challenge. We want to change to the Vertex shader, because the Vertex shader is responsible for positioning all of the meshes within our multi-mesh instance. Well, all the meshes determines the position of all the vertices of whatever mesh has this material. So let's change over to the Vertex shader, and we get access to the vertex information for each of our blades of grass. And we're going to start by just offsetting all of the vertices, and then from there we'll build up more and more complexity as we try to add movement. So we want to offset each vertice in our blade of grass, and we don't want to offset them when they are near the base. If they're near the base, we don't want that to move around, because if the base that's where the roots are. It shouldn't be moving. So we want our value where the UVs are near the bottom, like with the color, we want there to be little displacement, and near the top, we want there to be more displacement. So let's get that information. We want to grab our UV again. And in exactly the same way as the last one, we want to decompose it and get the X value, get the Y value even, a vector 2 decompose, get the Y value passed into a 1 minus. And we can see how this looks by just offsetting our current vertex by this value, and then we'll see everything start displacing. So if I add our current vertex value, so this is the position of every vertex in our mesh. If we just offset that by this UV value, we'll start to see some changes in our game world. So if we pass this vertex into an add, and this we want a vector 3 add down here, we want to pass our 1 minus value into the B property of that add. We'll now have all of our original positions with whatever the UV is added on top. So we should get no displacement at the base and displacement in some direction happening around the top. So if we collapse that and we collapse the shader view, we should start to see we're getting lines as all of our blades of grass are moving, but the important thing here is that the bases of these blades of grass are staying in their origin, and as they get further out, they're all moving out from that point. So that's good. We are offsetting our vertices, but we want to offset it first of all over time and using noise to get waves of motion. Noise being a 2D texture that you use to create semi-random changes over an area, put too simply. So let's return to our shader editor and let's start combining noise into the mix. So we can get noise with a texture 2D parameter. If we right click on some empty space and add a texture 2D parameter, we can rename this parameter to wind noise. I'm going to drag the sampler 2D into a texture 2D. And when I do that, it'll set up this texture 2D properly. When you create a texture 2D node, it is expecting a sampler 2D object that will tell it what the value in the texture is at the different points on the texture. By default, it's set to this texture mode. When you are using a value you're providing from a parameter, you need to change it to sampler port. But you can see when we dragged it in here, it changed it to sampler port by default. So now we have our value, and we want to combine this noise with what we have down here. So the way we're going to combine the noise with this value is we're just going to multiply how far up the grass we are, this value, by the output of the noise. So we're going to pass these into a vector 3 multiply. So we've got our noise going in the A value and our UV 1 minus value going into the B slot, and then we can plug that into our addition here. In the inspector, click the drop down for wind noise, and we're going to select a new noise texture. And we're going to want a very lumpy generic noise without too much intricate detail on it so that we get broad motions across the grass. So if we click this noise drop down within that noise texture, we can select a new fast noise light object, expand it, and within there we can control our noise type. That's not too important to me because we when it makes noise, it has one broad layer of noise and complexity that's added on top. We're going to remove that complexity. So we're going to go into this fractal drop down and we're going to change the type from FBM to none. And now you see we get this very broad lumpy noise. The grass should be moving in a bit of a more interesting way. So yeah, you should see we're getting some jagged motion across as the noise is changing the value that's sampled, and we're getting a bit more varied motion. We can now start scrolling that noise over time to make it move and make it look like the wind is rustling this patch of grass. In order to pan the noise texture, we're going to need to control the UV that's updating the point of the noise we're reading. And there is a function for moving a noise texture, and that is a UV panning function. So if I search panning, we get a UV panning node, and we can take the output from that and put it into our sampler port. We want to pan the node based on what the current time is. So we're going to want to pass the time in some form into this offset. If I just drag that offset into a time node and we return to our view, we will see we have our grass is moving like nuts. They're all offsetting in exactly the same way at the moment, but the grass itself is moving. That looks silly. Okay, so we're going to want to control the part of the noise texture we're reading from based on where the grass is in the world, so that they'll all move independently of each other. We expand the shader editor. We need to grab their current position in the world. We are going to grab that with the node position world function, the node. We want to grab the X and Z coordinates of this, because we don't care how high it is, we just care how far along and how far into the mesh we are. So we're going to decompose this vector3 with a vector decompose function. And we're going to compose this as a new vector2. So I'm going to drag the X value from there into a vector compose and change it to a vector2. We can now drag the Z value into the Y slot, and instead of having this 3D world position, we've got a 2D world position of how far along and how deep it is. I'm just going to add the current time to that. Alright, I'm going to add the time to that. So I'm going to take a vector2 add function, and I'm going to pass the current time into the B channel for that. And then I'm going to use this result in the offset. So now we've got a different value for our time based on where our node is in the real world. We noticed it was moving much too quickly a second ago. We're going to control that by decreasing the scale. So change the scale of the panner to 0.1, and now remove it at the 10th of the speed it did just then. So if I collapse this, and we get a good look, we'll see all of the grass is moving, and it's all moving independently. It's moving much too much at the moment, though. In order to decrease how much the grass is moving, if we jump back into the shader editor, we can go back to this point where we are multiplying all our values together, and we can multiply it by a smaller value so that the actual offset itself decreases. So let's pass that multiply into this another multiply, and change the second value of the multiply to be 0.1. So now all the offsets are going to be a 10th as big. And if we pass that into the add and return to our scene, we have lovely grass swaying in the breeze. And with that, the grass is all set up. Here are some examples of it in use in a project. One important step, when you're making your levels in Blender, it's also important to create the meshes you'll use for the bases of your multi-mesh instance. They don't have to be connected physically, so long as it's all one mesh, we can scatter our grass on top with those multi-meshes. If you want me to cover more foliage, or have me cover, for example, having a player displace the grass underfoot, let me know in the comments. Thank you very much for watching, and I will see you in the next one.